Okay, guys, we are continuing on the chapter 15, and then we have midterms going this week. I mean, so just check the due dates of it in the quizzes section on the iCollege. So we'll finish, I hope, today, chapter 15. We are by far at least one or two lectures ahead. That's give us time to review. Then I will ask for the final exams. They can give it to me earlier. At least I will have what the content in it, so we can make a review. Okay, guys. So we talked about this economics and the urbanization of our cities and how to make resources sustainable and how to and manageable, how to manage those resources. So many cities lack adequate housing. That's really true through the globe. Some cities they don't have. You have slums. One of the largest slum in the in the globe is, I think, found in Brazil. Brazil has one of the largest, followed by India, I think. I'm not sure which one is bigger, but I think the Brazilian slum is the largest by size, but the Indian will be by people living in. So because the population of India is huge, it's almost 1.5 billion. No, how much they are? Yeah, 1.5 billion. China is less a little bit, 1.4. But they said no, China is higher. But I think India is more than China in the population. I think China is 1.4 or 1.3, while the India is 1.5. That's my thinking. Although some if you read in some papers, they tell you no, China is leading, but India does not have any restriction, birth control restriction, no. So that's the reason they are growing more and more. And therefore they have slums, not in the size compared with Brazil, but they do have huge amount of density of people in those slums. Around 100 million people have no home at all, and that's really true, especially in developing countries, in poor countries. Urban challenges in the development world, in the developed world, that will be different in the developing countries. So the urban challenges are how to get all this, the sustenance of the resources is very, very important. But by far the challenges is less compared with the developing countries. Starting with the old Greek cities, you can see if you look at their model, they did a way they can really sustain their life at that time. They have channels through the cities for collecting and then distributing the rivers, tap water. They have a very good systems there. So now the challenges is always the financial challenge, because you have to build highways, you have to build the infrastructures of highways, telecommunication, and waste plant management, or there is a waste plant to collect all the waste, not only in the landfill, but you can recycle all those wastes. And you have seen a lot of people are putting like aluminum can in the recycling nowadays container, not in the trash can. So therefore, we can recover the aluminum out of those cans. So, as I said, this is always challenging because it's the status of the cities financially, economically, population-wise, all this affecting our sustenance. Transportation, as I said, infrastructure is very important. So getting people around within a large city is one of the most difficult problems, or part of the problems in the city. And again, if you have the highways are packed with a lot of automobile, they idle a lot. The idling time of those cars consumes a lot of fuel, and this fuel will come and then dumped inside the air, which is really affecting the air quality. So once compact cities now have spread over the landscape in a pattern development called spiral. So this is helping the crowdedness inside the city, especially the highways, for example. That's one of the major problems. If you are far away and you're going to work, you spend 2 hours on the highway. That means you consume a lot of fuel, and that's whatever waste coming out of the fuel. And if your catalytic converter is leaking or is not efficient, some of the stuff will get out into the air. So there is no way to get around this. So, and that's you'll see people are going all over outside the cities because they get out of this. You can see this is sprawl. So they are spread out all over in the outskirts of the cities, at the edges of the cities, far away from the main center of the cities itself, because it's too crowded. So this is even in Europe the same trend. It's the same trend. Now, however, if they work in the city and they are far away, that's a problem for the environment, because they will be consuming during idling time in the highways. A lot of fuel will be burned out, and depending on the efficiency of catalytic converter and the filters, will be how much waste of this fuel coming out as nitrous oxide, as carbon dioxide, as sulfur dioxide into the air. So that's another issue. But at least they will live much healthier than inside crowded cities where you have a lot of other problems. So and this is that's what we say. That's a major problem when you have too many people living in a small. In a city that's not really equipped to handle millions of people at the same time. And if you have millions of cars per day going from one way to the other way, and the idling time is calculated, and you can estimate how much fuel is combusted and then dumped inside the air, which affecting the air quality, depending on how efficient your car is. So older cars, they tend to leak a lot of fuel, and they can have a lot of fuel waste coming out into the air. The freeway system was designed to allow drivers to travel at high speed from source to destination without ever having to stop. Yeah, well, that's really true. But you have this from 3 o'clock to 7 o'clock almost. They call it rush hour. And rush hour, you sit there for a couple hours. I was teaching at Clarkston University about 28 when I came to here, 27 years ago, 27. and I was in Snellville in my house, so I spent about 2 hours from Snellville to Marietta, and sometimes 3 hours. So that's a lot of fuel is combusted, and some of it is vent into the air. Can we make our cities more livable? Yes, the answer is yes. Yes, the answer is really yes. It depends on us how we smart dealing with our sustenance, and how smart are we in dealing with managing our resources and our cities. So it says one option proposed by many urban planners is smart growth, which makes effective use of land resources and existing infrastructure by encouraging infill development that avoid costly duplication of services and inefficient land use. Smart growth aims to provide a mix of land uses to create a variety of affordable housing choices and opportunities. I mean, it's always in our hand, but sometimes it gets out of the hand if you have this space of the city there, but the population is growing too fast or expanding too fast. Then you have this crowdness, which will really affect the environment negatively. So, and that can be seen really in the cities of China. Most of China's big cities are really very, very crowded. Same thing with India, because they have the largest populations there, over 1 billion people there living in the big cities. So, I mean, in the country as well, but in the cities, you get a lot of people living there, and their cities are very, very crowded. The most crowded cities in the world are found in China and India. So this is a fact. This is really a fact. And I think if we look at the statistics, you will see those two countries, they have the major lung cancer. They don't reveal those data, but my intuition will tell you they are the two largest countries in the world. They have lung cancers because their air quality is so bad. Regulations, policies are very weak, and just is too much of crowd there. So too much crowd, too many cars at the same time, too many trains at the same time, too many buses at the same time. It's just you have too many millions of people there, so at the same time going to work and coming out of the work. So what you can expect? You can expect a lot of tower poisoning, air poisoning, and all this stuff here. That will affect, especially the air quality. That affect lung cancer, but they don't reveal the correct numbers. They don't. I don't think so. They will reveal it, but that's my intuition tell me. It's just too much crowd and weak policies compared to any other countries. So they have too many people there. So cities can promote sustainability or sustenance. Yes, they can sustain their cities by making the cities, they call it green cities. There are models there in California. You can look into this. There is a Gap headquarters there. They're trying to make it all green with all the facilities nearby. So there is some encouragement there. There's some cities are encouraging companies to have small, tiny, they call it green villages within the city itself. So encourage green building techniques, locate everyday shopping and services to reduce automobile dependence, encourage walking and bicycling for short trips, promote diverse, flexible housing, make cities more self-sustainable, equip buildings with the green roofs. So As you can see, some big building, they do have they plant some plants. I mean, some plants in their roofs, and I saw it sometimes. They put some plants, and that's really helping to create a lot of oxygen and take in all the carbon dioxide out from the air. Economics resources management. Like many of our environmental issues, improving urban conditions will ultimately be decided by economics and policy decisions. That's always true. That's what I say. If you have countries that have very weak policies, you can't expect there will be that much of an improvement in their management of their resources and their sustenance of their resources and managing their resources. So, like many of our environmental issues, improving urban conditions will ultimately be decided by economics and policy decision. Then that you can look at the whole thing here. And can development be sustainable? The answer again is always yes or no. Yes, if we have the right approach. No, if we have the wrong approach. If you have the correct approach, yes. If we have the wrong approach, then it's no. So, but all in all, I will say now the people are more now focused on this issue, this making their cities more sustainable. But still, we have still issues in the big countries, as I mentioned, like China and India. How we can continue improvements in human welfare within the limits of Earth's natural resources. As I mentioned that before to you, that some of the resources will disappear, will not stay with us in millions of years. For example, the fossil fuel, crude oil will disappear, will not stay. Will come to the point there is nothing on the Earth. So natural gases will come to the point it will disappear. So therefore, technology is coming in to help to recycle or to improve those type of resources. Development means improving people's lives. Sustainability means living on the earth renewable resources without damaging the ecological process that support us. Sustainable development is meeting the needs of the present without compromising the ability of the future generations to meet their own needs. Yeah, so that's as the our great grandfathers millions of years, we don't know how many millions of years back, they left us the globe in a good shape, and we have to do the same thing. So we should not be selfish and just think about ourselves and not think about the new future generations to come. So this is very important, and that's what's the effect. That's what the idea of sustainable development. So we have to think about present and the future for the future generation. So if we do too much damage for the environment, for our sustenance, for our managing the resources, that will affect the new generation to come. Instead of those resources will disappearing in millions of years, maybe thousands of years. You see that everything will be reduced in time. So therefore, the people are coming after us. They might not find their life that easy. So they might find all those resources are already taken, already gone. So, and that's another issue we have to think about. Definition of resources. Our definition for the resources shape how to use them. Classical economics assume that the natural resources are finite, as I told you. They are specific and they have limit. Finite means they have limitation. They can't go forever. Resources such as iron, gold, tabor, and land exist in a fixed amount. That's all the minerals are in fixed amount. All the crude oils or fossil crude oils, they are found in limited. Natural gases are in limited amount. All this they can run out of this from this globe within, say, not 100 but thousands of years, and some of them may stay with us for millions of years. Those are call them. They are really such as tabor. Tabor will stay with us for millions of years to come. However, if we misuse or abuse this tabor system, then it might not be drinkable. Like now in Europe, most of the river you cannot swim, you cannot fish, you cannot drink. So, but there is an effort there to clean up all those rivers, and that's doable, but it takes money and time and manpower to do those cleanup. New classical economics, not the traditional ones. The traditional ones, such as those minerals, they are found in a finite or limit amount. Although tabor found not that limited, but because we have ocean on the planet, so we can have always fresh water coming from the ocean by natural evaporation processes. However, if we misuse or abuse those resources, then we'll end up in a big problem for us and for the generations to come in the future. The new classical economists developed in the 19th century expanded the idea of resources to include knowledge, capital, and labor. Ecological economics applies the ecological ideas of system functions and recycling to definition of resources. So you have traditional economics that will tell you that all those minerals, all those resources, they have limit amount will found on this globe, and one day they will disappear. And the new classical non-traditional economics will add to this. Even we can add the knowledge, the capital, the labor as resources, correct? So the third type, the ecological economics, applies the idea of system function and of recycling idea. So this is the recycling idea. This is the recycling of those resources. So we can, although we know that we have limitation on the amount of those resources, but there is a way to get around this with the help of knowledge and with the help of recycling technologies. Correct? Mm-hmm. So new classical or non-traditional economics terminology here. There are three types of new classical or non-traditional non-traditional economics. So we have three. We have the throughput and the national product and the natural resources. So you have three of those. So we have three of those. So the three types of this non-traditional, not the old classical, but the non-traditional new economics. So the throughput is the amount of resources a society uses and discards or consumes. That's a definition. What is the throughput? The throughput is the amount of resources being used by the society, being used, being discarded, being wasted or consumed. Correct? And the throughput is commonly measured in terms of gross national product, GNP, which is the sum of all products and services bought and sold in economy. Natural resources economics extends the non-traditional economics point of view to treat natural resources as important waste sink absorbers, as well as source of raw materials. Well, that's you can see that is some of the natural resources found. You can find them as absorber as well as sources for raw material. Well, this is really true in some of the minerals. Minerals can be using as a raw material. I can tell you some of those raw material for other stuff. Like calcium carbonate. The calcium carbonate is like a white chalk. It's a very nice. You can use it as absorber, and you can use it as a raw material to get calcium out. Calcium is needed in many applications. Calcium is part of the bone structure, calcium phosphate. Calcium is very important in our electrolytes balancing in our body. Okay, guys, so those are, and you can even, you have a lot of other materials. You can use it as absorbers. At the same time, you can use them as raw materials. You have a couple of those chemicals are there on the market. Some of them, they are there. Ecological economics incorporate principles of ecology. So here just show you the solar energy, solar energy that's coming from the sun, and that's the ecosystem. Then you have this, the blue one, the box here. This box here has two boxes. This one here, this is man-made capital, and the big one here outside this box here, that's the natural capital. Natural capital found in nature without the interference of humans. But this is the capital made by the humans. So humans taking advantage of technology, recycling those resources, and put those techniques to boost up economy. So you can see the natural capital, or the main source of the capital, which is our main capital here, coming from natural resources. And then you have man-made capital. Capital means profit, money, wealth, correct? We have just the natural wealth coming to us from the natural resources around us. Okay, so, and you see this always, cycling is the key. This man-made technology, recycling is very, very important. As I gave you this with the aluminum, it's better to not dump aluminum inside the trash can, put it in the recycling can, so we can get the aluminum back again and reuse it. Ecological economics treats the natural environment as a part of the economy. See here, this the ecological economics treats the whole outside, the natural environment outside us here, as part of the economy itself. It acknowledges the value of ecological services. So, renewable versus non-renewable resources. Well, non-renewable resources, they exist in limited amount, and they will disappear. Limited amount in certain amount of time. So limited amount in certain time, limited time. So everything is limited, the time and the amount. That's with the non-renewable resources. That's non-renewable. Renewable resources, opposite. They have an open time, and they have the open or unlimited time and unlimited amount. So it's always time and amount. So you can time, and amount. That will differ both of those. This here, they have limited, or let's say limitation, in those two, 1 and 2 factors. And this one here, no limitation. No limitation. So that's the time, and the amount is really very important. So if we can recycle the resources, and we can have these resources for almost forever. So if we have really good technology to manage those resources, we can have them around us for almost, for not forever, but for long time. And the amount will be just open for us. And here give you examples of this. Look at the example here. We said the amount of this non-renewable. We have minerals. We said minerals, fossil fuels, natural gas. Natural gases is more than one gas. We have even fresh tap water. All those they have limitation in the amount. So can we make them renewable, staying for us for a long time? The answer is yes. The answer is yes. The answer is yes. This crude oil, minerals, if we can have technology to recycle those, they can stay with us for long time, for long time. So here this fresh tap water, they put it as renewable, means you can renew it, but it still has a limited amount. The amount of fresh tap water is limited because the evaporation of the ocean is not coming, it's not coming out that fast. It takes time to evaporate this ocean tap water, and then times to precipitate it, and then time to go to aquifer down to ground as ground table. So it takes longer time to this way. But if we can recycle it in a way that's make it open for us, yes, there is always technologies there. So let's see here. Managing non-renewable resources, as I said, iron, gold can be extended. Okay, those resources can be extended through more efficient use. That's what I said. You have to use recycling way. So some people, sometimes the pennies, they don't care about them. Sometimes they dump those pennies inside the trash. Well, that the penny is made of 80% copper, and a couple of the zinc and aluminum, so 20% or less than zinc, and a little bit of aluminum. So you have an alloy. You can recycle those pennies. If you have millions of those pennies, you can get, I don't know how many grams of copper out of them and how many grams of zinc. So So it's always the our attitude toward our resources. So those are resources. Those we use those to make. We use copper and zinc and aluminum. Those minerals or metals to make pennies or to make quarters, whatever. So, and it's waste to dump those in the trash. You can still collect them and send them to a center. They will take it from you. They'll send it this, and they can get the copper out of them. You can recycle them. Recoverable sources of non-renewable resources are always expanded by technological improvement. That's what I say. That's an example of the copper pennies. The pennies, they have 80% of them is copper, and less than 20% zinc, and the leftover is, I think, it's aluminum. It's an alloy of mixture of metals there. So you can recover those elements and sell them, and then you can reuse them. Copper, you can make from the copper tubing and all the other stuff. On the other hand, renewable resources can become exhausted if they are managed badly. That's what I put emphasis. It's up to us to make our life and our environment better to live in, and if that's our decision to make those things working very well. So if they are managed badly, so you'll see all those disappearing after a while, and not in a very short, not in millions of years, maybe thousands of years, some of them maybe hundreds of years. But if we have a good managing plan and good recycling plan, you can have those resources, especially minerals, maybe millions of years to come around us. Scarcity can lead to innovation. Well, if something is scarce and very limited, not that much of it is found, so then we have to think, we have to scratch our heads to make a replacement or to correct for this scarcity situation of this. We have to use technology there to help us to recover the situation. So here it is said in 1970, study of resource limitations was published called Limits to Growth, a complex of computer models had examined several scenarios, and they came out with they came out that's all this the pollution in the industrial output, fast growing population, depletion rates, and all this stuff here has a negative impact on our environment and in ourselves as well. Most of these models predicted that our population will boom and bust as we run out of natural resources and drown in pollution. Now that's really true in some as a cities, in some countries, but that's not always true everywhere. So that's the case. People are now very, very aware, and believe it or not, China is spending now about $2 billion just for green technologies. They want to get rid of this air pollution and air smog. They have a lot of soot and air smog there. So they put a lot of money now, China. They're in the process to improve their situation. Underlying a faulty assumption of this view is the idea that natural resources which we depend on are irreplaceable. Well, as I said, they can be depleted very fast, or they can be recycled and stay with us for many millions of years to come. It depends on us. It really depends on the people on this planet to make their life very nice and better, or make their life miserable. So It's up to the mankind to do that. So many criticize this model made by many computers there because it underestimates technical innovations. That's what I say. Technology is always there to help, and those models are just crude models. It's not really taking all details about our technology, our innovations. It's not. It's going for just numbers. They are looking for numbers. Number of air pollution, tower pollution. They go for numbers and they make a model based on. But really, it's up to us. Again, it's up to humans to make innovations, new technologies. Then we can survive for longer time, maybe millions of years to come. The models, those models, again, they the models said because of poverty, pollution, fast growing of people, that's caused it's like, will be like a big mishap or catastrophe coming on the people in the future. Well, people criticize that model, as I said, and they said you have to have really technology there to help you and to help mankind there. So, and many really pointed out that scarcity can stimulate research and development that result in a new process and materials that extend our resources significantly. So, and that's really always true. Communal property resources are a classic problem in economics. One of the difficulties of economics and resources management is that there are many resources we will share, but nobody owns. And tower we don't own, ocean we don't own, air we don't own, correct? All those wildlife we don't own. All those stuff, it's open spaces we really don't own. But we share. That's our shared property. And as I said, we exploit those resources, but really nobody really clearly really see that we are really exploiting those open resources, correct? And therefore that has to come out through more regulations and rules, correct? More regulations and rules. For example, I give you some areas there are overfish, sort of fish. It's good to eat, but if you overfish this type of fish, you'll not find anything in the future. No offsprings will be there. So it has to be somehow of regulations, and rules that's to control those open resources, such as tower, oceans, wildlife. So in 1968, biologist Garrett Hardin wrote, "The tragedy of the commons," an article describing how commonly held resources are degraded and destroyed by self-interest. Well, that's human. It's up to the human themselves. We can make our life better. We can make it worse. Natural resources accounting. This accounting here is done by the cost and benefit analysis. You can see the blue one is the benefit curve, and the red one is the cost. The benefits are really declining, while the costs are always increasing. So the benefits are decreasing, and the costs are increasing. So if we can get a good management here, and you can get to the P0, that's there. And that's here. You see the graph axes. Here in the x-axis pollution prevented, and here how much the dollar spent. And this is just on the pollution topic. This curve only relates itself cost and benefits for the pollution only. So you can see the benefits is lower, but the cost is higher. The cost is very, very higher. And that's the pollution prevented. So that's because all the type of diseases, cancer disease and all type of diseases kind of pollution make kidney failures, liver failure. So all the stuff here is just in the x-axis, and the y-axis how much dollars spent on this. So you will see the cost is to fight this pollution, which is causing all these illnesses, all these diseases, all this damage, not for us, even for for environment around us. The cost is increasing while the benefit is decreasing. And this is called CBA, this cost benefit analysis, processing, accounting, and comparing the cost of a project and its benefits. The project here is preventing pollution. Should CBA include natural resources accounting? I will say from the point of view, yes. Yes, not only the pollution is one, but we have other items we have to think about. So values such as wildlife, non-human ecological system, and ecological services can be incorporated with natural resources accounting. Yes, we can count a lot, not only pollution, but many other stuff besides the pollution. In the theory, this accounting contributes to sustainable resources use because it can put value on long-term or intangible goods that are necessary but often disregarded in economic decision-making. One important part of natural resources accounting is assigning a value to ecological services. This is very, very important. Although this is this curve is crude, I mean, comparing how much the cost is, and that's not including this for one project, but that's the trend. You can see it in many environmental or ecology issues. You will see that the benefits is decreasing while the cost is increasing. So that's, you can find it every time. It's the same thing. Oops, sorry. Internalizing external cost. Externalizing cost is the act of disregarding or discounting resources or goods that contribute to producing something, but for which the producer does not actually pay. Usually, external costs are diffuse and difficult to quantify. So is those externalizing costs. So there's discounting and discarding goods that contribute to producing something, but for which the producer does not actually pay. Well, I will say nuclear plants, electrical power plants, they are using what? They are using tap water, correct? Not direct as a product, but they are using for cooling their reactors, correct? So that's indirect. They did not put the cost of this fresh tap water. They built the artificial man-made lakes to have this tap water. Now it will come in a point of the time this fresh tap water no longer sustainable. They have to find somewhere to dump it and then have a new, what they call it, a new fresh tap water to put in those ponds near those nuclear plants and then power plants. The idea, you cannot reuse this because it's so aggressive after a while, but it gets contaminated this pond with a lot of stuff going through, because this is pumped through the pipes, and the pipes can be made of whatever of metals can be rusted, and all the materials will come back to the tower. Those resources, the manufacturer is not really utilizing. It's dumping just from nearby river or nearby whatever huge lake. So using it for free, correct? For example, a farmer has another example for farmer. When a farmer harvests a crop in the fall, the value of the seeds, fertilizer, and the sale of the crop are tabulated. The values of the soil loss to erosion are not accounted for. That's always true. That's always true. That's another example. But the best example is the fresh tower built by the manufacturer of the electricity manufacturing companies, with using reactors, nuclear reactors or electrical reactors to generate electricity. And then after a while, this tower will get contaminated. It has to be contaminated. Where to get rid of it? Just dump it back somewhere else, and then bump new fresh tower for cooling system. So they utilize it for free. Because the river is open. It's open resources. New approach to measure real progress. Here is Genuine Progress Index, GPI. And if you look, here is the GDP, and here is, this curve just show you two things here. This the GPI, that's the index here. That's the index here. That's the GPI, and this is the GDP here. So, which is the GPI is an index that takes account real per capita income, real per capita quality of life, distributional equity, natural resources. So that's take in account the income, capital income, quality of life, distributional equity, and natural resources, depletion, environmental damage, and the value of unpaid labor. And you can see the GDP is higher than the GPI index. You can see this is in US dollar in the x-axis, and this is here in years. So you can see that the GDP is increases to 35,000. Yeah, this is the highest peak, and this is the highest peak of it. It stayed almost, if you look at this, the GPI almost what? I will say stayed the same thing, no change. That's not considered change, but here is the change. The GDP increases a whole lot, but the taking of GPI taking into account all life quality, income, environmental damages, pollution, all the stuff here, unpaid labor, but stays almost constant. But the cost, see here, the cost is increasing. Okay, so it is. Trade, development, and jobs. Trade can be a powerful tool in expanding our resources and rising standards of living. Too often, however, the poorest, least powerful people suffer in this global marketplace. These systems often keep the less developed countries in a perpetual role of resources suppliers to the more developed countries. For instance, the World Trade Organization, WTO, World Trade Organization, has issued numerous rulings that favor international trade over pollution, prevention, or protection of endangered species. Well, I guess they look at the business is more than the just environment or whatever you call it. So that's the trend here. So the WTO looks for the trade and businesses interest than more than environment interest. And that's really true. That's really true. That's really true. Micro lending. Macro lending finances a small-scale development project. So micro lending, if you have people, they can access huge amount of sum of money for loans. Then you can give them small loans. They call it microeconomics. In microeconomics, they call it macro lending. Macro lending is just can finance projects in the economy that's really affordable for people. They can't afford having millions of dollars in a loan. So if people, they don't have the resources there, financial resources, then the micro lending it's helping. This what we call it now programs for small business. Do you hear about small business? Mm-hmm. Small business economy. Yeah, small business economy. Those are small, tiny shops, not the big, huge factories. So they can get this micro lending finances to finance their small, tiny projects, and because they can afford the interest rate. So the more you take, the higher the interest rate. So if you take a loan, it costs millions and millions of dollars, so the interest rate will go up. The process of running a successful business and repaying the loan transforms many individuals, and that's really true. That's really true. And this is crucial. Small businesses is really sometimes is the backbone of the big economy. So the big economy is there, but small businesses there is really backbone. It's like a backup there for the large big economy. A big economy cannot survive without those small tiny business projects. Market mechanism can reduce pollution. Yes, again, it's up to the people to adhere to regulations and rules and make their life better, not miserable. So many economists believe market forces can reduce pollution more efficiently than rules and regulations. That's really true. It's up always the person, him or herself. Assessing a tax on each ton of carbon emitted could encourage business to reduce greenhouse gases, to avoid fines. As you know, that anytime there is venting of chemicals out without permission, that's got millions of dollars in fines. So that's and there you have it. Above this, a tax on each ton you are emitting, correct? So, but if you emit some dangerous stuff, so you get fined. Cap and trade system. This is another system. So to approach the upper cap, the upper limit set by the government on how much each country's sector-specific industry is allowed to emit. That's very important. And if you of that factory is of that company or that of that unit is violating this cap, that limit, they will be fined, and most of the time millions of dollars. So companies that cut pollution by more than they are required, they can sell their credits to another companies. They have difficulties managing this type of mandate, this type of pollution, they call it upper limit amount. So that's the case. So some people, some companies, they are good. They have built a very good green, and those are the 5 companies. An example of those companies. Those companies are good in building really green trend in their companies. The Body Shop, Patagonia, Aveda, Malden Mills, Johnson & Johnson. So those are among those best green companies. They have really good green, as I said, trend and application in their companies. Green design is good for business and environment. Well, that's always the case, acknowledging that heating, cooling, lighting, and operating buildings is one of our biggest uses of energy and resources. Architects such as William McDonough are designing green office projects. So, for instance, I gave you the example of Gap Incorporated, the company. Headquarters built in California is one of third more energy efficient. And I think if you look at the full PowerPoints, not the concentrated, the detailed one, you can see how their headquarters looks really built on a very green type of technologies there. So this is very, very good. If all the companies throughout the world will do this, that will help really reduce any pollution of the air, correct? So green businesses often create far more jobs and stimulate local economies considerably more than environmentally destructive ones. Wind energy, for example, provides about 5 times as many jobs per kilowatt hours of electricity than does coal-fired power. China has emerged as I told you before, China and now maybe India after them. So, but China is really investing a lot of money because I told you the most crowded, the most polluted cities are found in China number 1 and India number 2. So China is fighting this by putting $8 billion per year for research and development of technologies to combat this pollution, especially air pollution. They have major air pollution, and then secondly is fresh tap water pollution. So they have some of the rivers in China and India. You cannot, same thing like in Europe. You cannot swim, you cannot eat the fish over there, you cannot do nothing with those type of rivers and ponds. Takeaway points: more than half of us now live in the cities, and in generation, there are 3/4 of us live in the cities. Shortage of tap water, housing, and urgent problems is fast growing in cities of the developing world. Urban planning tries to minimize the strains of urbanization, transportation, which is the key to our economy. Economic policies are often at the root of success or failure of cities. Natural resources economics extend new non-traditional ideas to internalizing the value of ecological services in economic accounting. So those are just a summary of the chapter. I will stop here the